I am one of the TAs of the Sustainable Engineering Concepts and Life Cycle Analysis course. So, in this tutorial class, we will solve few problems which is based on the previously recorded lecture videos, that is 8 weeks lecture videos. So, here is the first problem. So, the problem says that the figure below shows the production of a steel sheet. The mass flow and energy consumption are indicated. Calculate the amount of energy and iron ore required per kg of product. Treat slag as waste. So, the question simply says that 1000 kg of iron ore, which is the raw material required to produce 200 kg of final product, that is steel sheet, and this E represents the energy flows. So, in this product processes to convert iron ore to steel sheet, these three energy flows are required, which is 300 megajoule, 800 megajoule and 600 megajoule, and this 700 kg of iron ore and 100 kg of clipping or scrap is it is the slag, which you should treat as waste, which is produced in these processes. So, first of all, for solving this problem, we will calculate the total amount of energy flow. So, total amount of energy required to produce 200 kg of steel sheet, this is equal to 3000 plus 800 plus 600 megajoule. So, this will be total of 4400 megajoule. Now, this amount of total energy is required per 200 kg of steel sheet. So, amount of energy required to produce 1 kg of final product, that will be equal to 4000, simply 4400 divided by 200. So, this is 22 megajoule per kg of product. So, in the second step it says that calculate the amount of energy and iron ore required. So, now we need to calculate the raw material required per kg of product. So, 1000 kg of iron ore is required to produce 200 kg of product. Therefore, 1000 divided by 200 is equal to 5 kg of iron ore, that is raw material, is required per kg of final product. So, this 5 kg of iron ore required per kg of final product is the final answer, and this 22 megajoule per kg of product is the energy requirement. So, coming to the second problem, this is the solution of problem number 1. Coming to the second problem, this is the application of IPAT equation, which you have been taught before in week 1 module. So, this IPAT equation is basically for the impact assessment. So, the question says use the IPAT equation to estimate the percentage increase in the amount of energy that would be required worldwide in 2030 relative to 2018 to estimate the increase in population and affluences. Assume that population grows 4% per year. So, this is your P, and that global economic activity per person grows 5% per year, which is your A. Assume that the energy consumption per dollar of GDP T in the equation remains at 2018 level. So, coming to the solution of problem number 2, first we need to consider energy economics cash flow equation, that is future value by present value, which will be is equal to 1 plus I to the power n. So, here I is the growth rate, n is equal to here. So, 2030 and we need to calculate with respect to 2018. So, that will be is equal to 12. Now, in IPAT equation, where P is equal to population, A is equal to affluence and T is equal to technology. So, if we put all our values in this equation, so this will be 1 plus, so P is 4%, that means 4 divided by 100 to the power 12 into 1 plus affluence is says 5% and technology remains at the same level. So, if you calculate this, this will be 2.88%. So, the second part of the question, it says that how much does this estimate change if the population growth is 2% and economic growth is 4%. So, now we will calculate in the same way, but now the population growth and economic growth changes. So, therefore, I is equal to P into A into T. So, now this will be 1 plus 2 divided by 100 to the power 12 into 1 plus 4 divided by 100 to the power 12, and we are assuming that technology remains at the same level. So, this will be 2.03%. Now, therefore, you can observe that before the impact was 2.88%, now the impact came down to 2.03%. So, there will be a percentage decrease which is equal to 2.87 minus 2.03, that will be 0.85%. So, this is the final answer of this question. So, coming to this is the solution of problem number 2. Coming to the problem number 3, it says that an energy concern supplies natural gas to its customers. Calculate the CO2 emission in gram per kilowatt hour that are released due to the incineration of the natural gas. Density of all the gases can be assumed as 821 gram per meter cube. So, first of all, there are three kind, this gas contains three kind of gases are there. So, CH4 methane, C2H6 and C4H10. So, this is methane, this is ethane and this is butane. Now, we need to calculate number of mole present of X gas per 100 mole of natural gas. Therefore, in the question it says the average fraction of methane is 85%, average fraction of ethane is 5% and average fraction of butane is 10%. So, the number of mole present per 100 mole of natural gas will be simply 85 mole of methane present in 100 mole of natural gas, 5 mole of ethane present in 100 mole of natural gas and butane will be 10%. So, the number of mole present, the unit is mole, that will be simply 85, 5 and 10. Now, we need to calculate the mass of this gases present per 100 mole of natural gas. So, mass of X gas per 100 mole of natural gas. So, for calculating the mass, we need to consider the molar mass of these compounds. So, C carbon atomic weight is 12 plus hydrogen atomic weight is 1. So, 4 into 1, there are 4 hydrogen, that into 85, that is the mole. So, this will be equal to 1360. Now, calculating the ethane at molar mass of ethane, 12 into 2, this is the molar atomic weight of carbon, plus 6 into 1 into 5, that will be equal to 150. Now, calculating atomic molar mass of ethane 4 into 12 plus 10 into 1 this into 10. So, this will be is equal to 580. Now, in the third step we need to calculate the number of mole present. Number of mole present of X gas per meter cube of natural gas, because in the final answer we need to come to meter cube for the getting the final answer. So, how we will calculate this? So, the density of all gases you can assume as 821 gram per meter cube. We will use this data. So, that will be 1360 divided by, okay, we need to sum up all this data. So, this sum will be 2090. So, this 2090 divided by 821, so that will be 534.24. This will be is equal to simply 150 divided by 2090 divided by 821. So, this will be 558.92, and in the third case this will be 580 divided by 2090 divided by 821, which will be 227.84. So, now we need to, in the third step we will calculate the number of mole of X gas. So, again we need to write this gas CH4 C2H6 and C4H10, and there is the sum. So, number of mole of X gas per meter cube of natural gas. How we will calculate this? So, we know that the molar mass of all these compounds. So, if we simply divide our number of mole of X gas per meter cube of natural gas, that is this divided by the molar mass of each compound, then we will get the number of mole present of X gas per meter cube of natural gas. So, this will be 534.24 divided by 16. 16 is the molar mass of this compound. So, this will be 33.39. Here it is 58.92 divided by 30. This is the molar mass of ethane. So, this will be 1.96, and in the third case this will be 227.84 divided by 58. So, 58 is the molar mass of butane. So, this is 3.93. Now, in the final answer we need to calculate the amount of CO2 production. So, for getting the CO2 production we need to calculate the amount of carbon which is present in this gas. So, the number of carbon we will consider first. So, the number of carbon is, in this case only one carbon is present. So, it is 1. In this case 2 carbons are present. So, 2. In this case 4. So, this will be 4. Now, we will calculate number of mole of CO2 gas will be present per meter cube of natural gas incineration. This will be simply number of mole of X gas we know, and now we know the carbon. So, that will be simply 33.39 into 1. So, 33.39 mole of CO2 will be generated due to the incineration of methane. Now, in the second case this will be 1.96 into 2, that will be 3.92. In third case this will be 3.93 into 4, that will be 15.72. So, now we need to calculate the mass of CO2 generation per kilowatt hour. For going to this, first we need to calculate the mass of CO2 generation per meter cube of natural gas incineration. So, we know the number of mole of CO2 generation. Now, if we simply multiply this value number of mole into the molar mass of this CO2 compound, then we will get the mass of CO2 which will be generated per meter cube of natural gas incineration. So, we will calculate that first. So, again we need to write this gas for easy understanding and C4H10. So, mass of CO2 generation per meter cube of natural gas incineration. This will be 33.39 into, we are calculating molar mass of CO2, not this methane. So, this will be 12, carbon atomic weight is 12 and O is 16 into 2. So, this will be total of 1469.16. In this case, this will be 3.92 into 12 plus 16 into 2. So, this will be 172.48. In the third case, this will be 15.72 into 12 plus 16 into 2, this will be 691.68. But the question says that we need to calculate in gram per kilowatt hour. So, this value now we require to solve this. Heat value is 10 kilowatt hour per meter cube. So, the mass of CO2 generation per kilowatt hour, we will simply divide these values to the heat value, that is 10 kilowatt hour per meter cube. So, this will be 1469.16 divided by 10, which will be 146.92. In the second case, this will be 172.48 divided by 10, that will be 17.25. Third case, 691.68 divided by 10, this will be 69.17. So, simply we now add this. So, the sum will be 233.34. This is the answer in gram per kilowatt hour. This is the final answer of this question. This is the solution of problem number 3. Coming to the fourth problem, it says how much amount of CO2 emissions will result from the production of 200 megajoule of usable energy from coal and natural gas. Efficiency of obtaining energy from coal and natural gas is given as 55% and the carbon content of coal is 85%, carbon content of natural gas is 70%, heat value of coal is 30 megajoule per kg, heat value of natural gas is given as 48 megajoule per kg. So, first we need to calculate the mass of coal and natural gas required to produce 200 megajoule of energy. So, problem number 4, we will calculate mass of natural gas required to produce 200 megajoule of energy, and it says in the question that 55% is the conversion efficiency. So, this will be is equal to your 200 divided by 0.55 divided by 48. This 0.55 is coming because 55% is given as conversion efficiency. So, this will be 7.58 kg. It means that this much amount of natural gas will be required to produce 200 megajoule of usable energy. Now, we will calculate separately similar way for the coal. So, mass of coal required to produce 200 megajoule energy, that will be is equal to 200 divided by 0.55 divided by 30. So, this 48 is actually the heat value of the natural gas, which is megajoule per kg, and heat value of coal is given as 30 megajoule per kg. So, this 30 will come is coming from that. So, this will be 12.12 kg. Now, we need to require the mass of carbon, because finally, we need to calculate the amount of CO2 generation. For calculating the amount of CO2 generation, we should know that the mass of how much mass of carbon is present. So, mass of carbon in natural gas, it is given in the question that 70% is carbon in natural gas. So, simply 7.58 into 70%. So, this will be 70 divided by 100. So, this will be 5.31 kg. Similarly, we will calculate mass of carbon for coal. This will be 12.12 into 85, because 85% is the carbon content of the coal. So, this will be 10.3 kg. Now, we need to calculate the amount mass of CO2 generation. So, for calculating mass of CO2 generation from natural gas, this will be 5.31 into 32 divided by 12. I will describe why I am doing this. 5 plus 5.31, this will be 19.47 kg. So, why I am doing 5.31 into 32 and 12? Because we know the mass of carbon. So, we need to calculate how much amount of oxygen will be required to match this value. So, we know that 5.31 kg of carbon is present in natural gas. So, according to the molar mass, so 12 gram or kg, for 12 gram or kg of carbon, oxygen requirement will be 16 into 2 gram or kg. So, that is 32. So, for 5.31 kg of carbon, we will be required 32 divided by 12 into 5.31 gram or kg of oxygen. Kg, this will not be gram, this will be kg of O2. So, that is why I am calculating the amount of oxygen requirement, and then simply I am adding the amount of carbon which is present. So, this is the answer for the natural gas. Now, we will calculate for coal. So, the mass of mass of carbon CO2 for coal will be 10.3 into 32 divided by 12, this plus 10.3. So, this will be 37.77 kg. So, this is the final answer. This is the solution of problem number, this is problem number 5. So, problem number 5, it says that a company's product are transported by long distance truck. The truck houses a maximum of 40 loading positions for Euro pallets, of which 30 are used. Calculate the degree of utilization of the truck. If 40 positions are fully loaded, it weighs 30 ton. For filling product, one can assume that 1 liter is equal to 1 kg, and below is the one table given below. So, first of all, what we need to consider that in the truck there are 40 positions, out of which 30 are used. So, if the 40 positions are fully loaded, then it weighs 30 ton, but we are using 30. So, we need to calculate the amount of weight which now it is carrying if the 30 positions are fully loaded. Then only we can calculate the degree of utilization of the truck, and it says that it is the filling product weighs 1 liter is equal to 1 kg, we can assume. So, how much? So, we need to calculate the weight coming from the beverage. So, 1 liter beverage carton is there, and we need to calculate the primary weight of primary packaging, we need to calculate the weight of secondary packaging, we need to calculate the weight of transportation packaging. So, these 4 weights we need to consider. So, coming to the solution of the problem. So, first we need to calculate the weight which is coming from the primary packaging. So, total weight of primary packaging that will be is equal to your 31.5 gram, which is given here. Weight of primary packaging is 31.5 gram. Now, we need to calculate the total amount of beverage carton, because that is the then only we will get the number of primary packaging. So, the cartons per pallet it is given 500 pieces, and there are 30 Euro pallets we are using. So, this will be simply 500 into 30. So, 31.5 gram is weight of each primary packaging into 500 into 30. So, this is in gram, we want the answer in kg. So, we will divide it by 1000. So, this will be 472.5. Now, we will calculate the total weight coming from secondary packaging. So, total weight of secondary packaging that will be is equal to 128 gram of weight for each secondary packaging, and we need to consider that how much amount of trays are required. So, in the question it says that corrugated cardboard trays, these are the secondary packaging. So, trays per layer is 10 pieces and layers per pallet is 5 pieces. So, the number of trays will be 10 into 5 into, we are using 30 number of Euro pallets. So, 10 into 5 into 30. So, 128 gram into 10 into 5 into 30 divided by 1000. So, this 192 kg, this will be your total weight of secondary packaging. Now, we will calculate the weight of transportation packaging. So, for transportation packaging there are several components. First we will calculate for Euro pallets, which is made of wood. So, this will be for the Euro pallets, the weight is 24,000 gram. So, this will be 24,000 into 30, because there are 30 number of Euro pallets we are using currently, divided by 1000 into 720 equal to 720. Now, we will calculate the weight coming from pallet foil. This will be the weight of each pallet foil will be 280 into 30 number of pallet foil we are using. So, divided by 1000 is equal to 8.4. Now, the only one item is remaining, that is our filling product or the beverage itself. So, for filling product, which we need to consider that 1 liter is equal to 1 kg. So, 500 is the number of cartons. So, filling product will be 500 into 30 and 1 liter is equal to 1 kg. So, into 1. So, this will be is equal to 15,000 kg. Now, we will simply add all the components to get our total weight. So, this will be 1392.9 plus, sorry, this will be your 472.5 plus 192 plus 720 plus 8.4 plus 15,000. This is the weight for primary packaging, this is the weight of secondary packaging, this is the weight coming from transportation packaging, sorry, Euro pallets, this is the weight coming from pallet foil, and this is the weight coming from the filling product. So, total it will be 16,392.9. Now, we can calculate the degree of utilization of the truck. So, the degree of utilization, which is actual load which now we are the truck carries, divided by the maximum load that can be carried by the truck. So, this will be 16,392.9 kg. So, now we need to convert this into tons. So, divided by 1000 divided by 30 ton the truck can carry. So, this will be the final answer will be 0.55. This is the solution of problem number 5. Coming to problem number 6, it says that the calculate the method detection limit. The short form of method detection limit you already know, that is MDL, with 99% confidence level for the following sample analysis results. So, these are the results given, and it is given that one sided critical t value at 99% confidence level is 3.143 for 6 numbers of sample. This value we are getting from the t distribution table. So, coming to the solution of problem number 6. So, first of all, MDL is equal to T n minus 1 alpha into standard deviation. So, we need to calculate the standard deviation because this value is already given in the question. So, for calculating standard deviation, we need the average value of all the concentration. So, average value or mean value of the concentration will be 8.1 plus 8.5 plus 8.4 plus 8.2 plus 8.3 plus 8.4 plus 8. So, there are 1, 2, 3, 4, 5, 6, 7 number of values. So, the average value will be 8.27 mg per liter. Now, we can calculate standard deviation, the formula of which is root over of 1 by n. So, x 1, this x 1 is equal to the first value we can consider, and x bar is the mean value square, plus x 2, this is the second value, minus average value square, plus we need to go until it is x 7 minus x bar to the power square. So, simply 1 divided by 7. Now, 8.1 minus 8.27 square plus 8.5 minus 8.27 square plus this I am getting. So, you need to calculate for all the 7 values. I am here only writing 3 values. So, 8 minus 8.27, this is my 7th value square. So, if you calculate this standard deviation will come as 0.166. Now, we can calculate our method MDL value using this formula. So, our method MDL will be T. So, n number of samples are there, 7 number of samples are there, and now alpha value we will write as alpha is equal to, so 99% confidence limit into standard deviation. So, this will be T 6, alpha is equal to 0.01 into standard deviation we know 0.166. So, this T value is 3.143 multiplied by 0.166, this will be 0.52. So, this is the final MDL value. So, this is the last problem of this tutorial class. Thank you very much and all the best for your final examination.